In this problem, we're going to need to use appropriate formula to determine the periodic deposit. So look at the information given here. For annuity, the periodic deposit here is missing. So they basically want to deposit, a certain amount of money at the end of each month for 15 years. And eventually, the value of the annuity turn into $180,000 at this interest rate compounding monthly. So in order to find the amount of periodic deposit, then we do have a formula for that. That formula tells us the periodic deposit will equal to the value of the new annuity or the financial goal times the interest rate over n. The bottom is open parenthesis 1 plus r over n raised to n times t minus 1. So this is the formula we are going to use. So in the formula, the A is the financial goal or the value of the annuity. And it's given as $180,000. And then the interest rate R is given as 4.5%. So convert that to decimal, that is 0.045. And the T, which is the time in years, that is 15 years in the problem. And the N, so N here is not explicitly given, but if it says the interest is compounded monthly, so basically give you a hint. So if it says it's compounded monthly, that means N equal to 12. So now we have all the pieces we need to calculate the amount of periodic deposit. So P will equal to 180,000 time 0.045 divide 12 close parenthesis, and then the bottom open parenthesis 1 plus 0.045 divide 12, then close parenthesis raised to 12 times 15, then minus 1. So now we're going to put this into the T184 to get the answer. Now let's enter everything into the calculator. Since there's a fraction bar in the calculation, so let's hit the green alpha button and the y equal to pull out the fraction bar and put the top first. So that would be 180,000 time parenthesis 0.045 divide 12 close parenthesis, move the cursor to the bottom, open parenthesis, another parenthesis, 1 plus 0.045 divide 12, close parenthesis, raised to n, which is 12, time 15, bring down the parenthesis, then minus 1, then close the parenthesis. So enter. So the calculator gave you a $701, roughly 98 cents. So it's a number with several decimals. So the calculator gives us the periodic deposit P should equal to 701.9879199. But remember, this is a dollar amount. We cannot deposit anything that is less than a cent. So this number has to be rounded. So look at the rounding they want us to do. So they want us to round the answer up to the nearest dollar as needed. So here, as you can see, it wants us to round up to. Okay, because in some other problem, they say round to, but in this problem, they say round up to. So if it says round up to, so that means the rounding rule does not apply here. So you're gonna need to round up anyway, even if the next digit is less than 5. So let's look at our number. So we want to round to the nearest dollar, so the 1 is the dollar, okay? And so we need to look at the number next to it, so that would be the 9. So in this particular case, it doesn't make a difference. Round up to or round to, they both gonna give us $702. So that is the answer that should goes in here. So $702. Now let's look at part B. So in part B, they want us to find how much of the financial goal comes from deposit and how much comes from interest. So let's start from deposit. We already know when we calculate part A that $702 will be deposited at the end of each month for 15 years, right? So given this information, we should be able to figure out the total deposit, okay? The total deposit made in this 15-year period. So the total deposit will equal to the monthly deposit, which is 702 times 12 months. So that will give us the amount of deposit made per year, and then multiply by 15. So that's the total deposit made in 15 years. So that amount is $26,360. So that's the total deposit. We answered the first part of this question. Then now let's look at the interest. So as you can see, this total deposit, basically that's the investment, right? That's the investment. And this amount of money grow, okay, in these 15 years. So at the end of 15 years, remember, it turned into 180,000, okay? And as you can see, the difference, so the difference is the interest earned. So now calculate the interest. We just need to do a simple subtraction. So that would be 180,000, okay, minus $126,360. And that will give us $53,640.